Um, Hello everyone. My name is Daniel Olabi, and I am a junior data scientist, stroke data engineer working at Amoye AI Labs. And today we'll be having a session on introduction to Kubernetes. So, are there any other people on this Zoom meeting with me? Emmanuel, Christopher. Okay, that's fine. Okay, so let me try to share my screen. Okay, so incoming. I want to move this thing away from here. Yeah. All right. So is my screen visible, Emmanuel?
Yeah, we can see it.
All right. Thank you very much. So we're going to be, like I said, we're going to be talking on Kubernetes today, and introduction to the basic concept of Kubernetes, trying to play around some things in Kubernetes. And so basically, what is Kubernetes? Well, to explain Kubernetes, we have to talk about containers, right? I think we should become familiar with containers. Containers are basically lightweight standalone executable packages that contain everything needed to run an application. So um, they they are isolated from the operating system in which they are running on by making use of runtimes like Containerd, Docker, Podman. I think Cryo. I think we are familiar with Docker mostly. So basically what containers do is they help us to abstract away applications in such a way that they package all the dependency the application needs, and they are not as heavy as virtual machines. So one particular advantage we get from containers is that we can run several containers on the same host as opposed to running several virtual machines. Virtual machines being hosts themselves. So, and when I talk about hosts, I mean, like I said, virtual machines. I think we should be familiar with that from AWS, Azure, EC2 instances. That's what I'm referring to as virtual machines. A machine could actually even be your own local system. So that's what containers are. And everybody knows about containers, and we've been using containers for a while, but it is very tedious to deploy a container application on several nodes, right? And manage everything at the same time and scale it. Because one of the major things that we need while we are talking about container and container orchestration in the first place is we want to deploy applications, right? And we want to make applications available to users. So if we are deploying an application and we're using a container and we're using a single host and we are trying to scale it and all of that, what is the difference between that and actually just deploying a monolithic, that is a standalone application on a virtual machine? So if we want to be able to manage several containers and take advantage of using container orchestration, that's what Kubernetes is for. So Kubernetes addresses the issues by using primitives and an extensible open API that can enable the interaction of several containers and also exposure of containers to clients. So everything I'm saying now is kind of very abstract and theoretical. I know that you have probably read a lot of things that are theory, so we will be working a little bit more hands-on today. So first of all, one of the things that we need, give me a second. One of the things that we need is Docker. So to get Docker, usually if you are running on, let me just do something, right? Coming. So I don't want to go through the nitty-gritties of downloading Docker because there are several what do they call it now, articles or official documentation on how to download Docker and get it on your system. One of the popular one is to just use Docker desktop, right? So if you are running on Windows or something, it's better to just download Docker Desktop on your system and then install it. This is, I think, is my screen visible, please? Am I being followed? Anybody? Emmanuel, Equal, Logosu. You guys can just talk. Thank you very much. It's good to get that feedback. So we can just download Docker Desktop, and then when you download it and you follow all the installation process steps, you will be able to do something like this on your system, and it is going to bring out all the options for Docker package and using Docker for working with what they call this now, containers. So usually you can actually just, if you are running on Ubuntu, you can do sudo apt install docker.io. So this will install Docker for you on your what they call this now, Ubuntu system, Linux system to be precise. And then one thing that happens when you install Docker is that you would have to always run it with sudo, especially if you installed it on a Linux system like I just did. If you install Docker Desktop, I doubt you would have to be using sudo. But like in order to do that, you just do use sudo user mode. You add your user to the Docker Desktop group by running this command here, Docker, and then you use expansion to get your user variable, because usually the name of your user for your particular machine is saved. And I think we should be familiar with bash script. If you are doing with bash and Linux, if you are doing introduction to Kubernetes, that's one of the very important things to have as foundation. Usually what I did now is, because I know that my user, can you see the name of my own user is Ubuntu. So whatever your own user is what is going to be used there, and you can run that command to add Docker to group so that you don't have to use sudo docker every time. And another thing that we'll be using a lot today is kubectl. So kubectl is what they call this now, is the command line tool that we use to interact with our cluster. So like I said, now we are trying to deploy containers on machines, and we want to be able to use several machines together, because that's what Kubernetes brings. It helps us to be able to use several nodes. We can have up to 10 nodes, up to 20 nodes, depending on how much availability we need for our deployed application and how much resources we need for it, right? But managing containers on several machines at the same time is not something that is very straightforward, and that's what we need Kubernetes for. So in my own situation now, okay, before I actually go ahead, I still want to carry along people that don't have access to cloud provider. So to do that, to use Kubernetes locally, you can use Minikube. So right now, I am not using Minikube. I'm going to inform you guys what I'm using later. But if you want to get Minikube, I just want to get all of this past. I think you should probably have those steps too in your material, installing Minikube, right? So come to the documentation site, and then you will see that these are the minimum specs for running Minikube on your local system, and then different versions of Minikube, whichever one that you want. Follow these steps and then run Minikube start, and you have your local deployments of Kubernetes, which is a single node cluster. Although that single node cluster, Minikube helps you to be able to still abstract away some complications and be able to create several nodes. So actually you are working on a single machine, but Minikube will make it so that you can actually create like 2-3 nodes and still be able to experiment with the nitty-gritties of how it will be in a production environment, right? So, but like today, instead of using Minikube, I am working with AWS, and I have provisioned 2 machines, 2 instances, as we can see here. I have them called K8s, and one is my control plane and one is my worker. So in Kubernetes, we have a control plane that manages everything that happens on every other node in the cluster. So the whole concept of a cluster is that you have a node that contains the API server and some other operators that helps in managing the Kubernetes cluster. And then we have other nodes that are actually just running your containers. That is the application that you're deploying. I hope I am not too fast. Am I being too fast so that maybe I can slow it down?
The speed is good.
That's okay.
All right. So to continue, you have a control plane, and then you have workers, right, that are going to deploy your application for you and run them. The whole work of the control plane is to make sure that it sends work to each one of the workers based on the availability of space and resources. You can actually also include the control plane itself to be part of the cluster running the application. And I'm not going to go to the nitty-gritty of that. I'm just explaining to you the environment that I'm using. So I have two machines provisioned. One is my control plane and one is my worker. And I have opened them I have used SSH to connect to them on VS Code here. And as you can see here, I have labeled them from my configuration file for remote. Let me try to open that. I think I have something here. And so this is my configuration file that I have locally on my system. I have downloaded the, what they call this now, the PEM file. I think we should be familiar with this. If we are not, that's not the whole point of what I'm doing today. I have just created this environment for ease of navigating from my control plane. As you can see above here, I hope it's not too tiny, and the worker, right? So these are the two machines that I'm going to be deploying my applications on. And yeah, so let's quickly get started. I think that's a lot of talking already. I probably will still do a lot more, but I want to limit it because I want us to try to play around with the Kubernetes abstractions to a good point. So now I've spoken about the cluster and why we need Kubernetes and leveraging the power of Kubernetes in scaling applications according to demand based on the number of nodes that you're using, and then all of that. So let's work with Docker, right? So today I have created a repo. Let me quickly go to the repo. It's not updated, but like everything that I am going to be doing today, I don't think it is very important that you people follow me hand in hand, and I don't think you can do that except you want to watch this video again, in which case I would have updated the repo before then. So this is the repo actually. I will just have to push some of the configuration files that I added recently there, introduction to Kubernetes. So you can just come to what they call it now, this repo, and clone it to be able to have access to everything that I am going to be working on. The username is Daniel Tomiwa, right? / introduction to Kubernetes. If you're interested in that, it's not like very important. So this is the repo that I will be working with today, and I have already cloned that repo on my own local. In this case now, my local that I'll be referring to is my control plane. My control plane that is going to be managing the cluster for me. So this is my control plane. I am on my control plane right now. So these are the folders that I have. I have cloned the repo here. Let me change to that directory, introduction to Kubernetes. And let's go to what they call this now. Let me just open duration prediction, right? So this is I just want to give us, because I think I don't know what track we are in, but I think this is still all kind of connected to machine learning and building machine learning models, making them available and all of that. So like say we have, I'm not going to be going through the nitty-gritty of this either. I just want to give us a broad overview of a machine learning workflow. They have imported all the libraries that is needed, read the file, and then code to do some, what they call this now, engineering of features and all of that. And then categorical variables. I'm not going to go into the nitty-gritty of this. That's not what we are working on today. And then, so eventually use a dict vectorizer. This is a library in Python that you can use to convert a lot of categorical variables and even the numerical ones. It will leave the numerical ones as they are, the categorical variables maybe to like one auto-encoded colons, and transform them into something that we can use to train a model, basically. So let's say we train a linear regression model, and then we write function for reading the data frame instead of just going through this dirty way of reading it all together. We have a function for reading the data frame, and then this is feature engineering, combining two features together into one, and all of that. And just these are things that probably happen, right, when you are building your model, and then you train your model, and then you pickle it and dump it. So what I've done here is this linear regression model is the model itself, and this DV it is the one that is helping me transform the data, input data into the same form that I am training it with. So like I'm saving this so that when I'm trying to predict on the front in production, whatever the request of the user, if because usually the request would be like you have, let's say we have three columns, which is the location, the duration of the. Now this whole workflow is for ride prediction, because I think that's very important to get an overview of what I'm talking about. This is for predicting the ride, the time it should take for a taxi ride, right? So like you need the several columns. So let's say we have all these columns from the user, and then we have vendor ID, we have pickup time, drop off date time. So usually maybe the user will say that, okay, my vendor ID is 2, this is the pickup time, and this is my drop off time. Your model is the one that will convert this into a form that it can predict with. That's why we need this dict vectorizer, right? To help us do that also in production, because when the user sends it, it converts it into that and predicts with it. So this notebook right here has been converted into what they call it, a script, because you can't run a notebook in production. You need to deploy a script. So let's say we're just deploying a simple Flask application. We have imported all of the needed libraries, and then the pickle file will also be there. This is the pickled file, right? linreg.bin. So like I'm opening it with Python, and then I have a function for preprocessing the ride prediction, and then a function for predicting what is going to be the duration of the prediction, right? This is basically just a service for users to find out how long their ride will take based on some features. But it has been simplified to the highest form of it. I think it can be more complicated than this, but like that's not the point of this session. That's why it is this simple. And so Flask application using the app.routes, and this is the root of the web, and then this is the predict endpoints, the root of the endpoints, and then the predict endpoint, which accepts post requests, right, for prediction of rides. So we use request just JSON to get that, and we process it with that function and predict. I don't want to waste time on this. This is not what we are working with. So pardon me for going blazingly fast through all of this. So create a dictionary which is going to be the prediction, and then we JSONify it and return it. And we are making sure that we are serving this on the local host. Now, if I run this script on my own local machine, right, and I try to interact with it, I can get through to it on this local host, right? Because this is the local host is usually 0.0.0 on port 8000, and that's how that is will work. But like when I'm deploying this in the container, it is still going to be the local host for the container, because it is 00. For the container now, I want us to see containers as like its own machine, but just really simplified, right? Like I said, it is similar to virtual machines, but it is more lightweight and more scalable than actual virtual machines, which are actually the nodes that we are deploying those containers on. I hope I am not confusing us, but you can just maybe repeat what I just said now, rewind it later on YouTube if you are watching from YouTube. So yeah, we have this script and we want to use Docker to package it, right? So let's say I go to Flask application, right? And then I have all the files. So usually you have created your script from your workflow, the predict.py script, and then all of these files here, this one I'm not going to be including in my container. It is just to test it. If I wanted to test it locally, I'm not going to do that. I feel like it's a waste of our time. So, and that's not where we're going. So, but you can just use this to test it to, as you can see here, I've put the URL request does post to this just to test whatever it is you have done here locally first. And then you will now package it, right? To package it, usually to be able to ensure that the same version of libraries, because there are several libraries, maybe in your workflow, you used scikit-learn. In fact, to package, to create this pickle file, you must have used scikit-learn to package your to pickle your model or something like that. So all those things, you need the exact version so that there won't be discrepancies between when you created the model and when it is working on the in production, and then you're trying to find out, okay, what is wrong. So there are tools to do that in Python. People use virtual environments. You can use ppenv. I use ppenv here. So usually, if you have a requirements.txt file, let's say I created a requirements. I did not, because I think I just gave it the values I want. Usually, you can just do ppenv install. If you do ppenv install and you specify the packages, let's say sklearn equal to 1.1, Python equal to something, it is going to run and install all those packages and create these two files automatically, right? The pip file and the pip file log. They're just to make sure that whatever it is I install when I am working locally, I can move them into production and use them at the same time. So sorry about that. Now, when you have those two files, you need them in production, right? And we will use Docker to move them. That's what we use the Docker file for. I hope I'm still not too fast. Time has already even gone a lot. So so I think I kind of lost my thoughts train there. Where was I? I was talking about the produce.py file. So we use this Docker file to move all those. Okay, yeah, the virtual environment. So you can use ppenv, you can use venv, you can Google that, how to use ppenv, what is ppenv for, what is virtual environments for. It's very important when you're trying to deploy your model and handling all the packages. So let's go to the Docker file now. Usually when you're creating a container, or when you want to create a container, you're not creating a container immediately. You're going to create an image, right? It is the image that when you are running it becomes a container based on the container engine that you have on your machine. So right now here, I am going to be using Docker file to create the image. So from Python, you can't just create an image from nothing. You have to start from somewhere. So maybe we already have all these popular software that we are using, having images on Docker Hub. If you go to Docker Hub, that's an online registry for images, right? If you go to Docker Hub, you're going to find let me just say repositories. Oh, okay. I think my network is not very great. I hope you guys can still hear me. Am I still audible?
Yes.
Yes.
All right. Thank you. So let me go to explore. All right. So as you can see here, we have Nginx, which is a web server. We have BusyBox. We have Ubuntu. We have Python, Redis, Postgres. You can imagine any one of them. They already have images on some online repository that you can use as your base image based on what you want to do. Since I know that I want to deploy a Python application that is a prediction service, like a machine learning prediction service, I'm starting from Python Slim. You can check for whatever version you want on there. I choose Python Slim because it is slim, as the name implies, and it's not too heavy, and I don't want to deploy something too heavy. So I'm not going to go through all the what do you call this now, possible commands that I can give Docker or using the Docker file. If you want that, you can just go to Docker. Google is your friend, and it has all these things. All these guys already have what do you call this now, sites and documentation that you can go through. So here you can just go to docs if you really want to find out about how to work with Docker, and then maybe what do you call this now? Reference Docker file reference. So like as you can see here, we have a lot of they will talk to, if you read it, you can spend time on it because it is actually interesting. You will see them talking about the various things that you can do, why you should do what and what of all of that. So I'm not going to go through the nitty-gritty of that here. Right here, I'm using the run command. Run will run that command on my container when it is running. So pip install pip, which is a package manager I need to install other things. And then pip install pipenv, like I told you guys already, I will need to install pipenv in my production software too, so that I can install the packages that are in this pip file log. So I'm installing pipenv, and then work directory will just create this folder for me in my container, right? In the root directory, I will have a directory called app, and then I copy pip file and pip file log into the current directory being that app that I created, because I use the work directory here. So copy pip file and pip file log. So you copy these two files into that container for me. So let's just look at it like what Docker is doing for me is this is the container, and then this is my own local directory. I have created all this file here. I'm starting from this image, and then I install these two stuff inside these two packages inside my container. I make up my work directory. I copy these guys into the root directory, and then I run pipenv install system deploy. So I'm using pipenv to just install all those packages. These are just options for that installation. I could have as well just run pipenv install, but this is going to make sure that I'm using pipenv to install it in a deployment situation. It's not so important when you're working with small scale applications, but when you're working with large scale applications, it will help you to derive the most that you can from that particular machine. So that's why I'm using this. So then copy predict, and so this my actual script that is going to help to run the prediction, and the model itself that I want to use for the prediction, and copy them to the current directory. That's what dot is. So, and the current directory, like I said, is the app. And then I'm exposing these ports on the container. So I think we should be familiar with ports. I'm not going to explain ports. I still have, okay. So now command Python predict. So like what I'm doing here, some people will use entry points here. They kind of mean the same thing, but they are different somewhat. You can go and find out the difference between command and entry point. So what this is going to do is that after having done all of this in my container, it will run this command, right? So which is actually my service. So once I run Python predict.py, it's going to start. I would have run that here, but like since I did not create a virtual environment and all of that, and I don't want to go through the rigors of doing that, you guys can try that on your end. After what do you call this now? Creating pipenv. After installing pipenv, you can do pipenv shell, right? It will enter the pipenv environment for you, and then you can run this application locally before creating a container for it. So here, after having run all of that, it is going to run the application for me, and it will be exposing the application on port 8000 on that container, right? So so I just wanted us to get some background on that. So what after creating all of that, we will do docker build the tag that we want for our Docker file. So let's say that if you are pushing this to a online repository, it is advisable, or it is imperative actually, that you use your Docker username. As you can see here, my own Docker username is Danny Tomiwa. That was a mistake, but like just ignore it. Danny Tomiwa. So like if I want to create this image now, I'll do Danny. Okay, I think I went ahead of myself a little bit. If before you can push to your hub, you need to do Docker login, right? When you write Docker login, it's going to ask for your username and your password, right? And you put it there. It is not asking for mine because I have already logged in. As you can see, the existing credentials are valid, already logged in into docker.io, right? So run Docker login. If you ask for your username, you put it. Ask for your password, you put it. I'm talking about the same username and password for this account, so that you can push images there and pull from there too, right? So then now I can build my image and push it there. So Docker build -t, call it Danny Tomiwa like this, which is actually my own username and what I want to call it. So slash, let me call it rider, right, for now. And the current directory that I am building the image based on the current directory. As you can see, I'm in this Flask application directory, and all these files is what I need to build the image. So once I run this, it is going to run all those steps for me. Mine went blazing fast because I have built this image before. So it's going to go through each one of those steps one by one. You will see it's running showing you when you're installing a new package from Python. It will install Python Slim, it will install pip, it will install pipenv, and eventually create the image for you, right? So now I have an image. So let me see Docker images, right? This is the image that I created just now. So localhost, but you can see there that created 3 hours ago. I already created this image a long time ago. If you are just creating your own image, you're going to see it there. And this localhost will most likely not be there. This is because I am using Podman, and this Docker that I'm writing right here is actually not Docker. I'm using Podman as the container tool. There are several container tools, like I told you, container runtimes. So you can pick the one that you want. Docker is widely used. That's why I am deciding to call it Docker for you guys, and you guys can use Docker too. So going on, after building the image, you can push the image, right? Docker push this image to the registry. So Docker push Danny Tomiwa rider, and then it will push the image to the registry that I have already logged into, right? Are we following me, please? I just like to ask this from time to time so that I know that I am not just speaking to myself and I have people
Yes.
Yes,
Yeah.
we're following you.
All right. So thank you. So now if I come to my Docker Hub here, I will find that image that I just created, my profile, repositories. So look at it here. This was not there before. Last pushed a few seconds ago. So this is the image that I just built and I pushed it to this repository. It is kind of like GitHub that you can put code there and push there and pull from there. So now I have this image and I can use it in my configuration files for Kubernetes. So let's go and settle on Kubernetes. That's enough about Docker, because today is about Kubernetes. For Kubernetes, you need kubectl. I don't know if I spoke about installing kubectl initially. If you want to find out how to install kubectl, you can just search it. I think I'm already 30 minutes into this session, and I don't want to talk about all those basics again. Let's try to work with it. But I'm pretty sure, like I did initially, if you Google install kubectl, it is going to have a site, and you can follow it and see how to install kubectl. And once you have it installed, if you write kubectl, this is what you're going to get. You get all the possible options for kubectl, right? And then now that I have already configured my cluster, if you are using Minikube and all of that, after having set all of that up, you can do kubectl get nodes. So now, as I told you before, I have 2 nodes, right? This is my control plane node, and this is my worker node. If you come back to AWS here, you will see that we have control plane node 172 dots. What do you call it now? Where is it? I probably have to click it. Yeah, you can see the private IP address of that node here, and then this is the control plane. So that's the same thing that is showing me here, that this is my control plane node and this is my worker node. So other things that we can run is kubectl get API resources, right? Okay, let me see, get API resource. kubectl API resources, actually. kubectl API resources. So these are the resources that you can have on your Kubernetes cluster. It is a lot. It is a lot. So there's no need to disturb yourself about knowing everything. At some point, you have to know a good portion of them, but like you can only know something after having used it and having experimented with it. So as you can see here, we can have persistent volume claims, we can have persistent volumes. I think we'll still talk about that. Maybe not to do, maybe in the next session, because these sessions are going to be 2. We will have pods, which is the smallest abstraction of that Kubernetes works with. So I think I have spoken at length about containers, but when we are working on Kubernetes, Kubernetes has another abstraction that it works with, which is called pods. And it is inside pods that your containers will run. And when pods are deployed, pods are, like I said, they are the smallest abstraction. Like we will talk about, if you did sciences, and we'll talk about the smallest composition of matter is mass or something like that. So, or matter or something. I think I just said nonsense, but I think we get the idea of what I'm trying to say. So pods is the smallest abstraction that Kubernetes works with, and your containers are going to run on the pods. So we have this as a resource. We have secrets which are encoded. I'll talk about secrets later. We have API services. We have cron jobs, which are like containers that have time limits. They run for a particular time. And jobs, cron jobs and jobs are similar. We have other things. So, and we'll talk about the major ones that you need. And I think the first one I want to talk about is deployment. So kubectl get deployment. Right. So kubectl get deployment, no resources found in the default namespace. So what I'm going to be trying to do is that as I am seeing things, I will try to explain them so that we just have it at the back of our mind. So a deployment now is an abstraction above deployment pods. So a deployment is what you are going to have to create replica sets, and then replica sets are going to create pods. So let me do kubectl get deployment replica sets pods. Right? No resources found in namespace. So I just want to talk about these 3. The pod is the smallest abstraction. A replica set is, like I said, look at all these guys, all these resources like watch loops, like operators, like controllers. I'm using a lot of words, but like let's just have this idea behind our head that there are things that just perform their own task. The task of a pod is to run containers, right? The task of a replica set is to make sure that it is running a particular number of pods, right? So like what the whole work of the replica set is just to make sure that the pods is the number specified by the user of the cluster. And then the deployment will create a replica set that will in turn create a pod, and through a deployment, we can have other configuration for our application that we are deploying, right? So I think this will make more sense when I start working with it. So let me kubectl. I'm coming. So let me create a deployment for us to see. Let me create deployment, right? This is the command to create a deployment, and then let's call our deployment ride prediction, right? Or ride pred. Then what image do we want to use for this deployment? The image that I pushed to what they call this now, to the repository now. Actually, because I have not tested the recent changes I made on that image, I'm just going to use an earlier one that I used, that I pushed to the repository. Let me see if I can get back to Docker Hub. Sorry. I'm typing nonsense. Let's just get it. So Docker Hub. Please, we don't have all day. Be fast. So this particular image that I pushed is what you are just going to specify as what you want to run, right? Using kubectl. And when I run this, and I will explain some things to us so that we can get an idea of a better idea of how things work. So like I said right now, I'm going to be running this ride prediction. They are the same thing actually, but I don't want to take the chances. So I'm just going to work with ride prediction. Image is Danny, right? Tomiwa / ride prediction, right? which is what it is called. So deployment has been created. And what is going to happen is that, let me just do kubectl get deployment replica set pod. So as you can see here, let me watch it. I think I'm too late. So as you can see here, I'm watching what is happening in a deployment, in a replica set, and in a pod. This pod is trying to create the container for our application, right? And I think there's an error image pool. So it's not able to put the image. Let's go and find out why. So kubectl get pods. Let me do, if you want to debug a pod, you do kubectl describe pod, and then you use the pod name. This is the pod name on my cluster right now. And what I have here is ride prediction, image pull back off. Oh, okay. As you can see here, I did not specify the version of my image, right? So let me run that command again. That kubectl create deployment and specify the version, because that's one thing that is I did not specify the tag. The tag in this case is my own version, but like one thing that if you create an image and push it to Docker Hub directly, it will give you a default tag of latest. So usually it's good to have tags, because it is possible to have several images that are like doing the same thing, but like you have some updates on it. You did something in addition to the previous image that you have. You push it and call it version 2, version 3, and all of that. This is my own right prediction right now. If we check it, we see that it is version 1. So let me go back to that command and run kubectl create deployment right prediction version 1. I did not delete the last one. So the last one that that deployment actually is still there. kubectl get deployment. I actually like that this is happening. This deployment is still there. So it has deployed the deployment. The deployment has told replica set that replica set, I need this image in this number. Since I did not specify a number, the default is 1. So let me do kubectl get replica set. I can see that it says that, I have created the one container that you need, or the one pod that you need, rather, for this particular prediction service. So then this replica set already has done its own job. It has created it, and it has created the pod. So now kubectl get pod. Pod is now having an issue pulling the image it needs to run the application, which is what I already showed here. So you can see that all these guys are still there. The controllers are doing their work. The pod is the one that's not able to do it because of my own mistake. So to delete everything, let me do something. If I do kubectl delete pod this, right? It has deleted that pod, right? But if I do kubectl get pod, you can see that it's trying to create another one. Are you with me?
Yes.
Please,
Yes.
you guys should just respond
Yeah,
from time to time.
Yeah,
Let
it's
me know
because
that
we
I
are
am
mute.
not.
We are on mute, that's why.
That's fine. That's fine. All right. So now this container is getting created again. If I do kubectl get pod again, you can see that it is still trying to create that container, and it's still going to fail, because what is happening is that I'm not working with deployment again. Deployment has already done its own job. It has told replica set that, hey, this is the new directive from the orgas at the top. We need to create a pod. So replica says, go and get that done. And replica says, be like, okay, no, Allah. I feel like I'm just trying to make you understand. That's why I'm explaining it like this. And then it's to go and tell a pod that create this container for me in a single pod. And then the container is trying to create it, but it is unable to create it because of my mistake, right? And if I delete this container, like I did this pod rather, when I deleted that pod, you can see that it got created again. What is happening is that the replica set is saying that, no, I need go and create this pod for me. And that is what its own work is. it is going to be checking if what it has been told is the current state. If it is not the current state, it will make sure that it is created. Does that make sense to us? So that ensures that's the feature of Kubernetes that we enjoy, which is continuity. Because we know that one thing is certain: containers will die. When you create a container, over time it will die. But like with a replica set, the work of a replica set will make sure that when the container dies, and it checks that, oh, how many containers do I have now? 0. I'm supposed to have 1. It will create another container again using the same configuration that we had before. So to get rid of all these guys now, we have to delete their greatest abstraction here, which is the deployment. What's the name of this deployment? Write pred, I think. So if I do this now, and I do kubectl, why do I keep writing on page? kubectl get pod. You can see that no resources are found again. So all those things that were getting recreated before have been deleted. So I'm glad that I have explained that. I think we understand to a good extent how deployment works with replica set, works with pod now. I mean, I hope we do. So now let me create the deployment again using the correct kubectl create deployment using the correct version of what I want to do. So it's, as you can see now, it has been created. So let me do a watch kubectl get deployment, get the replica set, and get the pod for me. So as you can see now, this is running now. So my deployment has asked the replica set to create a pod and to create what it needs to do to have that configuration achieved. Replica set has determined that, oh, I need a pod running a single container, and then pod has been able to put the image, and now we have this pod running on my cluster. And one thing that happens when we create a container in Kubernetes is that it gives it a cluster IP, right? So if I do kubectl get pod -o wide, this means that I want to get, excuse me, sorry, more details from the pod. Right now, we can see that this pod write prediction is running, and it is running on this particular IP. This IP that we have here is the cluster IP, and this cluster IP is cluster scoped in the sense that almost every node or every node running in that cluster can see it. So let's do something interesting. Let's send a call request to that particular service that we are running on the cluster now. So now, I don't know if we are familiar with requests as a library. Request helps us to abstract some of these things out. But like when you're working with command line and you want to interact with an API, you can use call. And call here is specifying that I want to send the PU location of 10, drop-off location of 50, and the trip distance of 40 to my service. And the type of contents that I'm sending to you is a JSON file, and it is a post request, right? So I want to send it to the cluster IP for this particular pod. So this is the cluster IP. Let me copy it. Control-C. So that cluster IP, I'll put it there. And then on port 8000, just like I told you when we were checking this predict.spy, that we are serving our application on port 8000, right? So let me go back to that. So if I copy this now and I paste it here, we can see that it has given me the duration, right? Everything I did not want to test locally, it has received this request, and then it has given me that the duration for your request is 26.43. I think this is in seconds. I'm not very sure what I coded this in when I worked on this. So if I go to the worker node and do the same thing, I'll get the same results because it is a cluster scoped IP, right? So the pod now has an IP address that we can use to interact with it. And this IP can be used to interact between two different containers and all of that. But one thing that is certain is that if I use this, let me just open my local directory, right? This is me opening terminal on my own laptop right now. Like I told you guys, when you see VS Code, this is the virtual machine, the worker, and then this is the control plane, right? But like if I come locally, my own system that I'm using locally here, and paste that code here, using that IP, it is not going to work. Why? Because the application that I deployed is only local to that cluster on AWS running those machines now. But my own local machine can't have access to it because, I mean, it is not exposed. So let my machine have access to it. I need to expose that deployment as a service. But before I do that, let me quickly go through. I hope time is really just running fast. My God. I hope we are getting one or two things from what I am doing. Are you guys with me?
Yeah.
Yes, very clear.
Thank you. Thank you very much. So now, I was planning on showing us this. So this is the initial way that people deploy their applications, right? We have a monolithic application, a self-sustaining application that is not like divided into microservices. And the user will just have a single node that it is interacting with. That node can be doing and undoing with other nodes as it sees fit. Maybe it is running a Postgres server on another node and all of that. But this is the old way that legacy applications are deployed, right? But now we have microservices in such a way that we are running several web servers on several nodes at the same time. So the user can interact with this node, another user can interact with this, node, can interact with this particular container or pod in this case. Another user can interact with this, another user can interact with this. And with this, we have scalability, because one thing that we can actually achieve with this is that if, for example, all these nodes, these circles that we are seeing right here, they are nodes. If all these nodes are spent in resources, we can do it in such a way that we have another resource spawn up immediately, and we have our containers running there using a load balancing type of service. I know we might not understand what I just said now, but I'll still explain this later. So let's look at this, the Kubernetes architecture. So right now, this is the control plane that I am working on. And I have on the control plane, the kube API server, I have the kube control manager, I have the kube scheduler. I know we have read a number of these things. And then we have worker nodes, right? The worker nodes are running kubelets. And so let me just give an example of a run-in of what happens, like I did with kube deployment and replica sets. We are using kubectl to interact with kube API server. And what we did initially when we did kubectl create deployment, when we ran this command, is that we are telling kube API server that, hey, help me to create this application as a deployment in your cluster. So what kube API server does when it receives that request is that it is going to retain a part of that message in its memory and persist it to the storage, right? And then it is now, and that's all it does. But this kube control manager is like the organ of kube API server. Kube API server does all the work, but kube control manager is a boss for kube API server. And then it comes to kube API server and says that, okay, what is the state of the cluster right now? And what have we not done yet? Kube API server will tell control manager that, I got this request. It could be the only one that I showed you now. Or maybe if we have multiple users for our cluster, another person might have told it that you should create some things. So it will tell it all the things that it has not created anyway. So let's just localize it back to what we created. And that's, they asked that a deployment should be created. It will ask, do we have that deployment already? It will say, no, we don't. And then kube control manager will say, okay, go and create that deployment for me. Once it tells it that, it will go and persist that particular operation again in the etcd store. That's okay, I am about to create a deployment, and then that deployment will be created. So the deployment takes over from the kube API server. The deployment is not like, okay, what do I need to do as a controller to achieve my goal? It is going to tell the control manager that I need a replica set. Kube control manager will come and ask kube API server again that, do we have a replica set for this particular deployment? It will say no. And then kube control manager will say, okay, go and create it again for me. I hope I'm not too fast in this demonstration. And are we understanding what I'm saying? Please, are you guys following me?
Yes, we are following you.
So now the kube API server will say that, okay, the replica set doesn't exist. It will create it. Then the replica set will be created and then say that, okay, what do I have to do for my own lifetime? I need to make sure that the pods are running. And then it will create the, ask the control manager to create the pod. And this is the back and forth that we have between kube API server and control manager until we have that pod directive to be created. So now the pod is not created. Do we have the pod created? Kube API server. Kube API server says no. Then it's okay, go and create the pod for me. Then the Kube API server will now ask the kube scheduler that where can I put this pod? The work of the kube scheduler is to keep track of all the nodes that we have in the cluster so that it will know where the resources are and where it can deploy that particular pod. So based on what the Kube API server, kube scheduler tells the Kube API server, is going to put that pod that we're asking for on a specific node. The kube API server will have told kube API server, the kube scheduler will have told APIs. Sorry, let me just use, I will stop using kube now because I think it's affecting my speaking. The scheduler will tell the API server that you can deploy it on maybe this node, and then API server will say, okay, that's cool. And then it will send the pod spec to the kubelet. So the work of the kubelet working on each one of these nodes is to receive the pod specification for that particular pod that we want to create, and then it will create it on the node to be running using this container D. Like I told you, like I told us, we can have other container engines running this. We can have Docker. Docker is the same thing as like container D. We can have Cryo and all other things. And then the work of the kube proxy is just to manage the local networking of those containers running on this node. I know I have said a lot, but I'm just trying to describe to us how all of this works so that it is not too abstract. Because when something is too abstract, you can't relate with it and you can't really work with it. So let's just go ahead with what we are working on. I hope we have gotten one or two things from all my spreading and stories.
Yes.
Let me, this is the worker. Let me go back to the control plane. Yeah. So right now we have that particular, what do you call it now? App running, kubectl get deployments. Let me check it again. And then it's saying that that write prediction is running and it is healthy, right? Time has gone. So let me quickly do something. If we, like I said, I couldn't access this particular deployment from my local machine, right? And that is not the end goal. The end goal is to be able to actually have users send requests to that. So the way they achieve that is through services. So if I want to be able to access this application from outside the cluster, I need to create a service from it. And there are different types of services. We can have a node port service. We can have a cluster IP service, and we can have a load balancer service, right? So if I want to create a service from this, what I'm going to do is I will say kubectl expose deployment. I think this is not going to work, but like, let me just do kubectl get deployment, right? So I have this deployment. So expose kubectl expose deployment, the name of the deployment, which is in this case write prediction, right? And then what else do I need to put in this command? Let me see. I think the port that I want to expose for this deployment, I need to tell it that it is 8,000. Like we already know, again, I'll reflect back to this, that we are serving our application on port 8,000. So kubectl, okay, I think this is get deployment. I want to run kubectl expose deployment ride red for port 8,000. I think I'm supposed to put 2 dashes there. So now this service is being exposed now, right? So kubectl get svc, get the deployment, get the replica set, and get the pod. I keep typing nonsense today. So right now we have this service is running. Kubernetes is running as a service, of course, because I mean we're using Kubernetes for everything that we're doing. But this is the service that I just created, service write prediction. It is running on cluster IP of this. And then this deployment too is running. I mean, we already created that before. We have the replica sets running, we have the pod running. So now this service here is what I need. So let me kubectl get svc -o wide, that is show me more information on this service. It is telling me right now that it is exposing. I'm coming. I think. Let me check something. All right. I did not specify the type of my service, right? So by default, when you create a service without specifying the type, it creates a cluster IP kind of service. So one thing I'm going to do right now is I'm going to delete this service, kubectl delete svc write pred, because we already have cluster IP, right? But like, let me now create that service again. kubectl. I hope my command line is visible to you guys. kubectl expose deployment write prediction, right? So let me specify the type of that particular service that I want. That I want type equals to node port. So what node port as a type of service will do is that it's going to try to expose my application on that node using this particular, using an available port. So type node port. So this service has been created, kubectl get svc. And now we have this service. So as you can see now, before we had cluster IP, but now we have node port as a type of service, and it is serving it on this particular port. So one thing that I can do, if I want to access my application from outside this cluster and all these nonsense that are right here, is I can come here and check my instances. Let me go and look at their public IP. The public IP of one of my nodes is this, right? So let me copy this public IP, go back to that call, what do you call it now? Or let me just come back here. I think I should have it on my. This is my local machine, right? And the last time we tried to access this service, we could not. So right now, this is taking longer than I expect. So let me check I think that call should still be there. So let me change this IP, right, to the IP of one of my nodes. The one I copied now, right? And then change the port to the port that it is, because if, as you can see here, I am saying that I am serving my own port. I told you that I want to expose port 8000 for that particular service, but it is now mapping that port, as you can see from get service now, to 31158 for the node that is as it is in the type of the service node port. So it is exposing, it is forwarding 8000 to 31158. So if I come here and put 31158, I think you can see now that I was able to get the duration of my ride, because I have exposed my application on my cluster as a service to others outside, but the type of service is a node port. Now, a node port cannot balance and cannot scale as well as a what do you call it now, load balancer. So those are their differences. I think we can identify the differences between a load balancer type of service, a node port, and then a cluster IP. A cluster IP is localized to the cluster. The node port exposes the application, but it cannot necessarily scale based on demand. But a load balancer, like as I think we should be familiar with that, you can just Google load balancer. What it does is that it is going to be creating more, it will do a horizontal scaling of our containers based on the request. And with that, I think it is already 1 hour. I actually had planned that we will start working with configuration files, but everything that I have explained will make more sense when I start working with configuration files, because the point is that we can't be going through these rigors of doing kubectl, do this, kubectl, do that. What we use kubectl for mostly in production is for debugging, maybe getting information on something that we're not very sure about, talking directly to the API server, right? That I explained here. Talking directly to the API server with kubectl. But when we want to deploy applications in production-based Kubernetes clusters, we use configuration files. So as I created a deployment, I can have a simple deployment that I have the configuration file like this. I will specify everything I need for that deployment, and then I'll create that deployment with this. I can create a service from that deployment too, using labels that I have not really explained, but I will explain, I think, on our next, what they call this now, live session. And then we can also have config maps, secrets. If you want to find out more on how to work with those, I think you should try your best to come for that next session. So that's the end of today's session. I hope we have gotten 1 or 2 things. So yeah, do we have questions?
I really don't have it. Hello, can you hear me?
Yeah, I can hear you. I can hear you.
Okay, so for me, I don't have any serious questions for now. I would like to run this on my own, probably listen to it and try to get my hands dirty. Then
Yeah.
maybe in the next class. Then if I have issues, probably if it's you that is on board, I can bubble it up then.
Yeah, I think I'll be the one on board again for the next session, just to continue what we are doing here. And it's actually I promise that it will be a little more interesting than this, because we will now, a lot of what we did today is boring. Now we'll start working with configuration files, and we'll see some other Kubernetes abstractions that we can use to do different things on our application on the cluster, because we still need volume provisioning and all of those other things. So yeah, I hope you were able to get 1 or 2 things anyways.
No, a lot. It's just to get the hands dirty, because this is my first time having anything to do with Kubernetes. Yes.
Yeah, that's fine. Kubernetes is fun. So just like my DB password says. Does anybody else have a question? I don't think we have any questions.
Okay, yeah, so you mentioned sometimes that clusters die.
Okay, I didn't say clusters die. But like, complete your question.
What was the term used? No, I just want to know why they die, why, and what's responsible for that.
Okay. Well, what I said is not that clusters die. I said containers die.
Containers,
right?
Okay, all right.
Yeah. Containers are what we get from the image that we created for our application, right? You can remember that I said we created an image for this, push it to the hub,
Docker,
and then we run that image as a Docker container. So what happens is that something it is a process. I don't think you can have something running on your system forever, right? Okay. Something will go wrong with it. Do you get? At some point, it might start hanging. Maybe something is wrong with maybe its memory is full locally and all of that. So that anything can make it die. It can just get corrupted. Right. So when that happens, the beauty of Kubernetes is that when that container dies, the replica set will be alerted that you are supposed to have 3 containers. 1 has died, replica set will make sure that it creates that container back.
Okay.
But like, I want you to note that I am using container in the sense of a pod, because the pod is the smallest abstraction in Kubernetes, not the container itself.
Right,
Yeah, container runs inside a pod. So
pod,
yeah, I hope I answered your question.
Very well, very well. Thank you.
Any other questions?
Yes. Could you share your GitHub repo link with us?
Okay, you want me to provide you guys with the GitHub repo?
Yes, please.
Okay, let me quickly get that for you guys. Code. So don't clone it yet, or even if you clone it now, you would have to do a git pull later, because I need to include some things that we will use. I mean, most of what we did today anyways is there. You don't need to come to this configuration file. So if you can just watch the video, the only configuration file here right now is Kubernetes, but like the Flask application is there, the duration prediction, IPYMB is there, and all of that. And I think I tried to put some of the commands that you need for running Kubernetes there too. So you can actually just clone it now if you want, but towards the next session, I would have updated it with some configuration files that we are going to be playing around with. And yeah, I just put that here.
Okay, thank you very much.
Thank you for that.
Yeah, sure. I think that's the end. I don't think any other person has a question. So I don't know if Christian is there. Christian, are you there, please? I don't think Christian. Okay.
So yeah, that's the end of today's session. And thank you everybody for joining. See you next time. Have a lovely weekend.
Yeah, thank you so much.